In this video, I will show you how to use the beam analysis tool. uniTank will automatically classify all the beams and girder data points into the beams class during auto classification. First, we will isolate these data points by showing only the beams points. Second, using the circle tool, we are going to define the central pedestal. You will want to try to position the elevation of this circle near the bottom of the central pedestal, although its exact location is not all that important. This is the area where all the rafters converge towards the central column. We want to block off this area because in this area, the points from different rafters get really close, making it difficult for uniTank to differentiate the center line of each rafter. If you find that the rafter center lines are jumping near the starts, you may want to expand this central pedestal area to improve the results. Third, we are going to automatically detect the beam boundaries. uniTank uses the column definitions to determine the girder locations that separate the rafters. If you find that the girders are missing, you should ensure that the columns have been defined properly. Columns are automatically defined during auto classification, so if you didn't use this tool to classify the data, you will have to manually add the column definitions. Fourth, we are going to automatically generate the beam cross-sections. This is the most time-consuming step, so you may want to run this and go for lunch, or at the end of your day. This is the step where uniTank goes through all the data points for each girder and rafter and creates cross-sections to detect the center lines. Once this is complete, you can review the results for each beam and adjust it as needed. Each beam will have cross-sections at every foot if you used the default settings. However, reviewing this many cross-sections is very time-consuming. So, when you edit the beam cross-sections, you can adjust the zoom to reduce the number of cross-sections you have to review. Using the cross-section image at the bottom, you can adjust the center of each cross-section by either using the keyboard arrow keys or clicking on the image. You can also adjust the tilt of each cross-section by using the fine-tune buttons on the side. Finally, if there are too few data points for you to be confident, you can increase the depth of the cross-section. When you are happy with all your cross-sections, simply go to the Analysis tab and execute the Beam Analysis tool to output the results. An individual graph will be generated for each beam similar to what you saw in the Edit Cross-Section dialog. During auto detection of beam boundaries, if you found that the rafter locations were not accurate, whether because there was severe deflection in the rafters or a systematic twisting of the entire rafter's ring, you can manually define the rafter boundaries using the point tool. First, delete the rafter boundaries that are incorrect. Then, using the point tool, identify the rafter endpoints on one side followed by the rafter endpoints on the other side, following the same order on each side. If you just need to redefine a single beam boundary for whatever reason, you can use the polygon tool to draw out the specific boundary and set only that specific boundary.